because IP address is also lengthy one. And one connection point I didn't told, one is that is how to use this OS layer for troubleshooting and OS and TCP IP layer comparison. Yeah, that is we will discuss. This is very small part I will tell, that is. So anyway, I don't give much notes, only notes you have want notes, then you have to read it from PPT only. Just I will give you how it is look like and what is the use of those things. Okay. What is the physical topology, guys, or a logical topology? So two topologies. Physical topology means the way you connect devices physically. So you have a computer and you have another computer. Are you connecting them directly or through some device, and how they will communicate? Okay. So the physical connectivity between the devices, is called a physical topologies. What is this logical topology? Logical topology is defined by IP address scheme. Okay, depends upon the IP addresses. Is these devices are in the same network or not? Depends upon the IP address. We have to define these devices are belongs to same network or different network. So that is a logical topology. So we are talking in a physical topologies manner, guys. So in different physical topologies are there. So mainly bus topology, ring topology, mesh topology, star topology. These are the different physical topologies are available. If I use a paintbrush, so then I can draw very faster way. Or if I use this one, it will take a lot of time. So main physical topologies are bus topology, ring topology, and mesh topology, and star topologies, and hybrid topologies. And some extended topologies are came, that is like some extended star topologies, point-to-point topology, point-to-multi-point topology, hybrid topology, and stuff. Okay. So if I draw here, it will take time. Lot of confusion is also there, but I will try to do that one. So you should not feel I'm copy pasting, right? So for that one, so I'm doing this. Guys, what is this bus topology? The devices are connected to a backbone wire. There is a backbone wire. The devices are connected to this backbone wire only. It's a single wire like this. You know, olden days, we use a cable TV network, means the cable guy is give a one big thick wire like that. Maybe if you see nowadays, this Reliance also giving this kind of wire. Okay, so this is the one single wire, and devices are directly connected to this cable. Okay, so these are all communicating. Devices are communicating each other through this cable only. So it is a very simple, very easy, very cheap. No complex. It is a very easy, very simple, and very cheap topology it is. So easy to configure, simple to configure devices. For example, this is PCA. Will communicate it to PCB, APC, BPC, CPC, like that also you can tell. PCB. So what is this topology? It is It's a bus topology. It is a bus topology. It is a bus topology. But there is a problem, guys. What is the problem? If this wire is got a damage somewhere, problem is occur. So you cannot communicate further. You can communicate A to B and A to C. A, B, C will communicate each other, but D, E kind of stuff is not communicating each other. Why? Because of the backbone wire is down here, so further communication will stop. And it is difficult to troubleshoot also. It is very easy to configure. It is a cheaper but difficult to troubleshoot. Why? Because of it is very big lengthy wire, single wire and lengthy wire. If something is happened to the wire in some place, then it is very difficult to find out where exactly issues occur and repair. Next one is we are using coaxial cable. If some guy asked me earlier, so where we use this coaxial, of course, for this purpose, coaxial kind of stuff is also useful. You guys understand what is the bus topology, how it is look like? The next topology, actually, if we make this one as a small size, that is a better option actually. Just for a smaller size, not this much smaller, this is little smaller. Okay, now we'll move this one here. Okay, so next one is devices. A device is connected to another device. Another device is connected to another device. Like that, one device is connected to another device. Finally, the last device is connected to the first device. So we'll see how it is look like. I will take arrow here because it's understandable with arrow. It is. If this device is connected to this, this is connected to this is connected to this, and this is connected to this, and this is connected to this. Okay. If you take the first one is like a APC, I given A will send a packet to B will send a packet to C send a packet to D will send to E. For example, I want to communicate from A to D, A, B, C, D. I want to send a packet from D to A, D, E, A. Okay, so it is a clockwise or anti-clockwise communication or both. That is called a double ring. So this is called a ring topology, guys. A device is connected to the another device is connected to another device, and the last device is connected to the first device. This is form a ring. So this is called a ring topology. Called a ring topology. Of course, there is a double ring topology is also there. Double ring topology means that is a reverse algorithm, means this is clockwise and anti-clockwise. Anti-clockwise connectivity is also there. So two connectivities. Each device are connected in a with the two connectivities. Okay, with the one way is clockwise, another way is a anti-clockwise. What is the use? Of course, it is also very easy to configure, but it is difficult to that is understanding these algorithms. It works based on the token ring algorithm kind of stuff, and we have to configure each and every device how they should communicate each other, how to forward the packets. We have to go to each and every device. You tell me. Okay, and it is very difficult to scalable. It means if you introduce a new device, then it is again you have to do connectivity. The entire you have to change the connectivity pattern. So you have to remove this connection. You have to rearrange the entire communication. So very difficult to scalable. What is the scalability? Ability to increase your ability to increase. So we will put a very smaller ability to increase your what we can say network size or size, whatever it is. Scalability means ability to increase bigger the size. So this is bus topology. Next one is ring topologies. So we'll see other topologies. Again, new drawing here. We'll see what will happen. Here also I'm taking some devices. So better keep small size. Smaller it is easy to write. Yeah, we'll take a bottom top kind of stuff. Okay, just like these two things. Okay, so somewhere from, so this time we take these wires only. If you anybody guess this what topology it is? Hmm?
Star topology.
Okay. So this is exactly say a mesh topology. Okay. So every device is connected to all other devices along with this one. So I need like this. I don't know. Okay. If you see, every device is connected to all other devices. So for example, this is A is connected to B and C. Okay, see this C and D and E, and B is connected to A, E, D and C. C is connected to D, B, A, E. E is connected to all other devices. Okay, so this is okay. It is shape out, but still no problem. So this is called a mesh topology, guys. So why we think it is a star topology? Because while people draw, to make it writing easy, they draw like a star first. And some people, in some places, even myself, I've seen some people tell that is a star topology directly. Okay, and they will confuse at the start to. Okay, because while drawing, it is mesh topology. Drawing is very easy, so they will draw like this. Okay, this is the PC, this is the PC, So because when you see a star kind of stuff, because from childhood days, you're habituated to see a star like this only. So then immediately our mind is triggering to this star topology. Even some people don't verify also. I'm not talking about you. I'm talking even the lecturer kind of stuff. Okay. Don't verify. They'll tell this is a star. Okay. So this is not star, guys. This is the mesh topology. So every device is connected to all other devices is called a we don't get a much space here. So no problem. Then where it is created, where it is created. So now this is the mesh topology. What is the use of this mesh topology? Again, guys, the mesh topology is a very complex. It is a complex, not simple. It is a complex, but it is reliable. Why reliable? Like a ring topology. If you take ring topology, a wire is disconnected, or maybe one device is down, further communication will stop. In bus topology, the backbone wire is disconnected, enter the further communication will stop. But in mesh topology, it's not like that. It is a complex. Every device is connected to all other devices. Lot of connectivities requirement is there, but it is a reliable means if a device is down, no problem, other communications are going on. A wire is down, no problem, remaining communication is going on. So communication won't stop. If BPC is down, A, B, C, A, D, C, E will work, will communicating each other. For example, A to C wire is down, no problem, remaining communication is going on. It is complex but reliable. Difficult and troubleshoot. These are the things. It's a difficult to scalability is very difficulty is there and difficult to troubleshoot. Okay, so that is about your mesh topology. Why I'm writing for a mesh topology? Why not for other topologies? Because still we are using a mesh topology. One way or other way, we are using a mesh topology. Okay. So that is a mesh topology part. Okay, guys, this is a mesh topology. The next topology is, of course, now that is our topology. Here we use a centralized device. All communications are depends upon this centralized device only. Okay, this centralized device is either hub or a switch. Use hub or a switch. Of course, the devices are directly connected to this centralized device. Devices can be connected to the centralized device directly. It is a very simple to configure and very easy to troubleshoot. Simple to configure, easy to troubleshoot. And it is not reliable as a mesh topology, but still we are using this topology in our regular network. Okay. So here it is. If you take APC, APC want to send a message to B, it has to send through this hub array switch only. So all communication should be going through this hub or a switch. So this topology actually we are calling it as a star topology. So in star topology, we are using a centralized device. We are using star topology. This is a star topology. We are using a centralized device. All communication is going through centralized device. If CPC is down, no problem. Further communication is going on. For example, D2, this cable is down, no problem. Remaining communication is going on. But centralized device is down, total communication is down. It is not a reliable, but it is very simple. It is simple and easy to troubleshoot, easy to configure, and easy to troubleshoot also, because we know where is the issue is happened, because we are using a simple to configure. I'll put like this: simple to configure and easy to troubleshoot. Simple, not complex. Simple to configure or easy to configure. Easy to configure, easy to troubleshoot, not reliable. Not reliability means if why if the central device down, network down. Okay, if central device is down, the network is down. That's the problem. So all communication go through this centralized device, but scalable. Scalability, ability to increase the network size. This is better. So it depends upon central device. What is the scalability thing? I will show you guys. This is another switch or a hub. Okay, another switch or a hub. Okay, so I'm having some other devices. Okay, for example, this is I have more devices. I want to connect all these devices in a network. For example, A, B, C, D, E. Well, these devices also there. So one hub or a switch, not enough ports to connect all these devices. For example, I have a more devices are there. Okay, not enough ports for a switch or a hub. What I will do, I'll take another switch or a hub. I'll connect the devices to this switch or a hub kind of stuff. Okay, and I'll connect these two devices together. Now it is become bigger. Okay, so like this, we can able to extend your star topology. So this is called a extended star topology. Okay, so this is main topologies, guys: bus topology, ring topology, mesh topology, and star topology. You guys understand how the topologies are there?
Yes, sir.
Yes, sir.
So point-to-point topology. This point-to-point topologies are actually, if you are connecting a device to another device, means a one PC to another PC is also a point-to-point topology. If you are connect a switch to switch, like extended topology, we can connect, that is also point-to-point topology. A router is there, the router is connecting to another router through WAN communication, okay, through WAN connectivity, like a point-to-point connectivity, okay. A device to device direct connection, we call it as a point-to-point connectivity. A PCA is connected to PCB, or a router is there, it is connected to another router in the WAN communication, serial communication it is a point-to-point connectivity. You know, I will go to router point only. Okay. So this is a point to multi-point. So of course, the switch we are seeing, one switch is connected to multiple devices. That is also comes under point to multi-point concept only. But here I am taking our routers or ISP routers are connected to multiple routers in the network, right? And also there are also connecting so different networks, right? So that is what I'm trying to say. One router is connecting to multiple routers, not from one point. Also we can connect from like this different interfaces wise also we can connect. Okay, so these are the point to multi-point connectivity. This type of thing is one device is connected to multiple devices. Okay, this is the point to multi-point connectivity. Point to multi-point. If you don't get this point also, yeah, it is good one, but try. So last one in this topologies, guys, I'm going to see this is the one good diagram actually. Tree topologies are one is connected to multiple things, but recently I found this is as a tree topology. This is also very good tree topology it is. Okay, the recently some people asking me what is tree topology. That's why I taken this picture. Okay, guys, look at here. This is the backbone cable. You can see it's a mixed topology only. It is. You can see there is a backbone wire, backbone cable is there. These topologies, see these separate topologies are there. This is extended like this. This is the direct nodes. The servers are connected to this backbone wire and create a one new topology. So this is a tree topology. And if you go to this PPT, guys, already I shared this link. So this is telling about how bus topology is there, ring topology, mesh topology, what is star topology also. Okay, so these are the your physical topologies. I hope you got to understand what is star topology. So you have to give, you cannot draw that, right? You cannot draw bus topology, you cannot draw the mesh topology, right? at a time of interview. So what to do, guys? You have to tell in the lines. So practice in the lines. What is bus topology? There is a backbone wire. So devices are connecting directly to the backbone wire. So they are communicating through backbone wire. It is very easy to configure, very difficult to troubleshoot. Ring topology, every device is connected to another device and the last device is connected. Every device is connected. So a device is connected to other device. A device is connected to other device. That other device is connected to another device. Another device is connected to another device. Finally, last device is connected to first device. It is communicating from one device to another device. You want to reach, you want to communicate, you have to send a message to a device, you have to go through this multiple device communication. Okay, so A to B, A to C, B to C, C to D, D to E kind of communication it is. So wording only, wording only. So you put a blank page and try to practice. What is ring topology? It will communicate either clockwise or anti-clockwise, depends upon the configuration or algorithm. Next one is, so if pollens, if any device is down, further communication will stop. If wire is disconnected, then further communication will be stopped. So that is called a ring topology. Then what is mesh topology? Every device is connected to all other devices. Every device is connected to all other devices. It is a complex but reliable. If any device is down, remaining devices will communicate each other. If wire is broken, a wire is disconnected, only remaining devices will communicate each other. Okay, so mesh topology also used in a, mesh topology. SAN use mesh topology. Okay, I'm giving this. SAN, storage area network, use mesh topology. Servers, in certain servers, core routers use mesh topology. Why? Because of reliability purpose. Next is a star topology. Star topology, the devices are connected to a centralized device. It can be a hub or a switch. Star topology, it is simple to configure, scalable, and easy to troubleshoot. But we need a centralized device. If centralized device is down, your network is down. But it is very easy to troubleshoot, means we can understand where is the issue. We can find very easily where is an issue, whether it is a device issue or it can be a cable issue or a centralized device issue, we can understand. And it is scalable, so we can extend the topology for a very lengthy size. Guys, that's the main topologies. Hybrid topology is a mixture of two topologies, like a mesh topology and star topology called a full mesh topology. Mesh topology, star topology called a mesh topology. So in a server, certain routers, core router side, we use this mesh topology plus star topologies also. And other topologies like a point-to-point, point-to-multipoint, and tree topologies also available. Guys, this is about your physical topologies. The leftover part is also very big. One is an IP addresses, IPv4, IPv6, and also private IP addresses, NACPAD techniques, and these are all there. Okay, it's a big topic. So tomorrow we'll finish this, the networking, how much is left over also. Finish it. I'm adding few points here, guys. What is simplex, off duplex, and full duplex? Okay, what is a simplex? It is a one-way communication, means you are sending, other side receiving. That is called a simplex. You are sending, other side receiving, no returns, one side communication. Off duplex. What is off duplex? Off duplex is a yes, either you are sending or receiving. It's a two-way communication, but only one communication only. Either it is sending or receiving. When you are sending, other side receiving. If you are, if other side they are sending, you have to receive. Best example is walkie-talkie is an example for off duplex communication. It means same line. Line is same, but while you are sending, you don't receive. While you are receiving, you cannot send. What is full duplex? Full duplex, there is no full duplex. Actually, it is a two simplexes. It is actually two simplexes. One simplex for sending, another simplex for receiving. So you are sending to one simplex, like you are sending, other side is receiving. In the other side, if they are sending, you are receiving. With two different simplexes. It's a two-way communication and using two simplexes to create a full duplex. Okay. And also I told certain commands, guys. One is a ping command. I think I told ping command. And I told about a trace RT command, ARP command also I told, and some other commands. And also ping testing command is also there. So you can also use the ping testing related information. It is there in the PPT, but we can see. Unicast, multicast, broadcast, also know this information is also useful, guys. Find out what is the unicast meaning. What is unicast? One-to-one communication. For example, I am talking to a person. So how to address the person with a name, right? I want to talk to only one person. For example, Sandeep, I want to ask a question. Sandeep, what is the unicast? So I told to address, specific address. I told Sandeep is a address to address, and I put a question. That is a unicast. Only to a particular device, only one address. That is a unicast. Multicast in a group, I send a message. Okay, so tomorrow class is at 10 o'clock. That is a multicasting. Within that group, people receiving a message. Okay, people receiving a message within the group only. Like these are the multicasting. It's a single address. You are sending to a single address but received by multiple recipients. Okay, what is a multicast? You are sending to, you are in a network. Okay, so multiple devices in your network. What is a simplex? So A send a packet to B. So A send a packet to B. So two addresses. That's it. But A send a packet to some address. So there is certain kind of address is there. So we don't know what is that is the address. Okay. So A send a packet to a address, and this address represent multiple devices. Okay. So packet sent to multiple devices because of this address. So that is called a multicast address, and it is a multicast communication. Like my two address is my WhatsApp group. So I send a message to this group means one single address only, but I send a message to put a message in a group, it will send to multiple people can able to receive this information. Okay, so this is multicast. Next one is broadcasting. Broadcasting do not require any specific address scheme. So broadcasting address is there. So broadcasting does not mean you are belongs to it or not. It will give it to everyone. Broadcasting is meaning is to everyone whether you are belongs to it or not. Multicast addressing is used by certain protocols. For example, you want to install a operating system in 10 computers through network, we use a multicast addressing. We use both unicast and as well as a multicast addressing because 10 computers need same data. 10 computers need a same data which is given by same server. One server, 10 computers getting same data, same request, same type of communication, same information sharing. So that time it is use multicast addressing. RIP version 2, EIGRP, OSPF are share their information to other routers using multicast addressing because one router is EIGRP, other router is also EIGRP protocol using. So both routers are EIGRP protocols. So they will talk each other in multicast manner. So this is the part. Next is broadcast. What is a broadcast again? So broadcast is one to all, means it will send those who are connected, irrespective of what protocol, what address it is, those who are connected in the network, so it will broadcast to everyone using broadcast address. Any cast is actually used by, any cast addressing actually used by IPv6. IPv4 use unicast, multicast, broadcast. But IPv6 don't use broadcast, instead broadcast it to unicast, anycast. Okay, what is this anycast? Instead of sending a message to everyone in the network, those who are IPv6 enabled in their adapters, IPv6 is enabled or not. I'll show you. So if your adapter is enabled with IPv6, so I'm taking one IPv6 adapter. See this. See local IPv6, link local IPv6 is showing, means this adapter is enabled with the IPv6. Okay. So this adapter having IPv4 enabled, means check mark is there, IPv6 is enabled. So this adapter having IPv4, IPv6. For example, if I remove this IPv6, means this adapter don't use any IPv6 communication. No IPv6 address, don't send or receive IPv6 type of communication. Okay, so it is purely IPv4. So IPv6 do any cast means any adapter having a IPv6, either IPv4 plus IPv6 or only IPv6, it do broadcast. It do any cast. If any device only IPv4, no IPv6, so that it won't send that to one. Okay, so that is the part. Broadcast means send a packet to every device, whether it is IPv4 or IPv6, don't mind. If device is connected, send the packet. That is broadcast. Any cast, IPv6 wise, okay, if adapter is IPv6 is there, send it. No IPv6, don't send it. That is anycast. Not only these guys, there are so many terminologies in the networking, you must know it. Baseband, broadband, attenuation, crosstalk, okay, bandwidth, broadband, broadcast, a lot of things. That's just for fill the time, guys. That's it for today. So tomorrow we'll completely see about IP address first, and anything left over we'll try to complete tomorrow. Okay. Compulsory read, guys.
Okay, sir.
Okay, compulsory. I taken a time. I didn't do hurry. Okay, as a no. Even I taken a less time or more time, whatever it is, we have taken a lot of time for networking. So I don't want to complete it hurry type, means fast open the PPT, 1 day, 2 day, complete. That is I have done. So compulsory go for it, and also I will share few animated videos. Go through that channels. Okay, I will share 1 or 2. Using that, you can go to that channels and also find out if you have any doubts. Compulsory reading. Now the time, guys, because of next week or other week, I don't know when is your version test, when is your communication skills classes. But once it is started, you are busy. Now you have a time. This week you have a beautiful time, and you don't have a test anything nowadays. Now you can concentrate more on the technical stuff. The as you said, take it is that is rotate learning, kind of rotate learning. So that is learn and keep memorizing it and start doing it. Practice if you have a knowledge, okay, and also associated with other friends, because there's some people already having knowledge on networking side, so you can take their help to understand, okay, and you can discuss. You have a time now, so put a afternoon 1 hour, 1 hour, 2 hour session. You guys put a one meeting with some different link, not my link, different link. Start discussion. If you do discuss in English mainly, so it is improves the way of speaking, means the you can able to speak faster. Okay. Usually I am in a Pune, when I was in a Pune, so little bit better. Now it is worse. Why? Because of all my colleagues and everyone. Usually we speak in Hindi or Telugu. So right, mostly we are speaking Telugu. For only 1 or 2 members, we have to speak in little Hindi, and outside Hindi Telugu only. Okay, we never speak. I no need to get a chance. I don't get a chance to speak in English again in general way. So that's again, it will backs my the speaking skills generally. Generally, I'm telling. Okay, guys, now it is the time. Study, start discuss. Put yourself one meeting. Okay, Google Meet is free. Okay, Google Meet is free. Take one, create one link, share within a group. So you guys will sit together and start discussing about any topic plus technical topic. Any topic also, but in English. So it will improve the wording, sentence construction, mind striking. Mind striking, sometimes answer, mind won't tell you that answer. Mind will don't help you to tell you that answer. Okay? Mind striking. You ask a question. Sometimes my mind is open. I will tell an answer. Sometimes more my mind will put a back, so is it answer, right answer, wrong answer. If I tell this answer, it is correct or wrong. Because I'm a trainer, no problem for me. You're a student and you're sitting in front of interviewer. Your mind won't give you any help. Yeah. Tell me, Faisal.
Sir, is there a way to determine which networking topology we have to use in any particular situation? Like, for
What it
example, if we
is?
are, for example, if we have to draw some networking topology, so
Okay.
is there a way to determine which we should use and which we should not?
Yeah, mostly we are using this star topology in a very core networking side, means servers, storages, core routers. That side we go for a mesh topology or a mixed topology, like a hybrid mesh and star topologies. Okay, so where we don't use particular topologies, like a ring topology, generally we don't go with ring topology. You're already seen three type of topology, that is the bus topology plus other topologies mixed into tree topology. Okay, so that's the point I got now. Okay, so that's it. Okay, guys, practice, study, practice. If better one version is, you guys take a one Google Meet link. Want someone create a Google Meet link, share to others, sit together, discuss everything in English only. Why English, guys? Because some people, maybe some people are very good, I don't mind about it, but some people may not good, but while speaking immediately. Okay, So you go to interview, you will tell me about yourself. Other than that question, it is very difficult because we face some issues with certain people. So initially they are very good, but at the time of interview, they can't able to tell about a very small thing, small details also they are unable to tell. So practice by conducting yourself a meeting and you can go through it. Okay, so that's the point. And also ask some technical questions in the meeting. You do asking some technical question, not required very depth questions, but basic questions. What is the differences? Put a question and try to tell an answers. Keep telling, keep discussion. It will improve your memory power. It will improve your wording, sentence constructions, and also ability to speak up. Ability to speak up also improves. That's what I'm trying to say, guys. So best one is if you have a time, create a meeting, take 1 hour, 2 hours, join. Those people are interested, join there, start discussion in English. Even it is a bakwas topic, also no problem. Yet you're trying to tell what is going on in China, Pakistan, or Bangladesh. Even that is also waste news, no problem. But speak up in English, so that will give good memory thing. Okay. So even it is a waste topic, also no problem. Sometimes, if possible, include the technical topic, that is improves much better. What is OSL layers? Tell me OSL layer numbers. Okay, what is this router? What is the search? What is the hardware? What is CPU? What is operating system? All these questions you can open it, start discussion. Okay, that we are missing nowadays. Okay, that's it for today, guys. Anything? Any